Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the introduction to T distribution. And first of all, let's talk about its characteristics. Uh, First point is it is a symmetric distribution, which is similar to the standard normal distribution. Next, the mean of T distribution is 0, but the standard deviation is different and it depends on the sample size. So to illustrate the statement given here, let's consider the graphs given on this slide. So for example, if n is equal to 3, so this is the smallest sample size, then you can see that the spread of the data here is the largest, okay, given by the red curve here. Now if you increase the sample size to 5, then the dispersion gets slightly better, so it is slightly reduced. Okay, the dispersion is slightly reduced, the variance is slightly reduced. Now when n is equal to 30, then you will see that it gives the smallest dispersion. The data here is much better. The dispersion of data is actually the smallest one here. Now as n increases, the shape of the T distribution will approach the standard normal distribution. So the standard normal distribution is given by this one, the black curve, labeled as Z. So this is the standard normal distribution, and you can see that for n equals to 30, so this is the T distribution when n is 30, you can see that there is a great resemblance between the two curves here. You can see the curves are sort of overlapping with each other. So then it becomes the rule of thumb that when n is greater than 30, instead of using a T distribution, you can have another option, which is to use the standard normal distribution. But both distributions can be used, as long as n is greater than 30. Right, next I'm going to explain how to use the T distribution table. So in this T distribution table, there are three sort of items that you need to know before you can use it. So the first one is you need to understand the values of T, which is given by the horizontal axis here. So the horizontal axis here represents the value of T, and you can see that here at the peak will be 0.0. So you can see the values of T here is to the right of 0, which indicates that the value here are going to be positive values, whereas if you have the value to the left of 0, those are the negative values. Now the T values here are given inside the table. So these are the T values. And you can see that the values here are all positive because they correspond to the values from 0 to the right. Okay. Now the area, which is also the probability, is given by this shaded region. So this is the area, okay, also known or labeled as alpha. So this is the area on the right tail of the distribution. So that is the second item. And the third item that you need to understand is degrees of freedom, which is usually will be stated beforehand. Okay, so in this table there are three items. The first is the T quantiles here, or the T values, the values of horizontal axis. So this one, and then area is given at the top here. So these are the areas or the probabilities, and then the degrees of freedom. So what is the degrees of freedom? Basically it means the number of values in the final calculation of a statistic that are free to vary. And I think I will revisit again this idea at the end of the chapter. So we'll just leave it at that first, and we are just going to focus on how we can use the t-distribution table. Alright, let's look at the first example here. We are going to find what is the probability that the random variable t is less than 2.603 and the degrees of freedom is given by S12. Okay, so I'm going to sketch what is the question is asking you to do. So basically this is 0.0. So the value here is positive, so we know that 2.603 is going to be on this side. Okay, so let's say that this is the value of 2.603, and it says that t is less, the random variable t is less than this value. So that means you are going in the left direction. So basically it is asking to find the probability going to the left. So which means this is the area that the question is asking you to find. So what is this area? Okay, or what is this probability? The same thing. So now we can start by first going to degrees of freedom 12. So where is degrees of freedom 12? It is somewhere here. And the next part is we're going to find where is 2.603. So this is the value of t. So now, so this is the value of t. So the values of t are given inside the table. So now for degrees of freedom 12, we're just going to read and find which value is the closest to 2.603. So the value that is closest is this one. And if you refer to the area here is 0.01. But notice that this 0.01, the area 0.01 here is referring to this area. So the area here is 0.01. For 2.681, the area is 0.01. Therefore, you cannot say that probability is 0.01. You need to do some sort of manipulation. You need to do some sort of you cannot get the answer directly from the table. So we know that in order to find this area, we need to take 1 minus 0.01, because we know that total area is going to be equal to 1 because total probability is 1. So 1 minus 0.01, then the answer is going to be 0.99. So that is the probability for the first question here. Okay. Right, next. How about the second question? The second question is asking you to find what is the value of t when the probability is 0.9 with degrees of freedom 1.7. 1.7 with degrees of freedom 17. So if I sketch the graph for this particular question, we know that the area is given as 0.9. So therefore we know that this is a symmetric distribution. So the area here is already 0.5. Each side is 0.5. So it basically says that t being less than this value here. So we know that the area is somewhere to the left, and the area is 0.9. So we know that for this part here, this is already 0.5. So we need some more to sum up to 0.9. So maybe up to here. So this could be 0.5, and this area from this to this is 0.4. So this is the area from this to this is 0.4. The area from this to the end is 0.5. So total is 0.9. Okay, so given degrees of freedom 17, so we can go straight to 17, which is this line here. And the problem is for this 17, so we need to find what is this t value at this point. So what is t here? Now we cannot directly get the answer from the table because we need to find this area. So what is this area? So that then it matches the area given on the table here. So if this is 0.9, we know that this area here is going to be equal to 0.1 because total area is 1. So this one is 0.1, so we can go and find out what is 0.1. 0.1 is the same as 0.10. So this is the area that we're looking for, and if you go and read, and the answer for the value of t is 1.333. Okay, so for this one, the answer is going to be t is equal to 1.333. Okay. All right, next is the last question, which is, what is the value of t when the probability is 0.005 with degrees of freedom 10? So if I sketch the graph here, this is at 0.0. So it is asking you for greater than some value. So we know that the direction is to the right. And you know that the area is very small, so 0.005. So we know that it is somewhere at the end because the area is very small. So this area is 0.005. So I need to find what is t in that sense. Okay, so based on this, we can read the table directly. We can get the answer directly because the area given here, because the area given in the question here is similar to the area sketched on this table. Well, now we go to degrees of freedom 10. So degrees of freedom 10 is this one, and you can go direct to 0.005. 0.005 is this one, and so the answer for that is 3.169. So this one is t is equal to 3.169. Alright, that's all for now. Thank you very much for watching.